Today we are here to learn about Chomsky hierarchy. In formal languages of computer science and linguistics, Chomsky hierarchy is the hierarchy of classes of formal grammars. A hierarchy of grammars, the languages they generate and the machines they accept. It was developed by Noam Chomsky in 1957. Noam Chomsky is an American linguist, philosopher, cognitive scientist, historian, social critic, and a political activist, who was born on 7th December 1928 in Pennsylvania, United States. Now, let's talk about grammar. A grammar G can be formally written as a four tuples N, T, S, and P, where N is a set of variables or non-terminal symbols. T is a set of terminal symbols. S is a special variable called the start symbol. P is the production rule for terminals and non-terminals. A production rule has the form A goes to B, where A and B are strings on Vn and at least one symbol of A belongs to Vn. For example, we have a grammar G1. Here in this grammar, we have S, A and B all in capital letters are non-terminal symbols, and A and B in small caps as terminal symbols. S is our start symbol and S goes to N. So here we can see our productions are S goes to AB, A goes to small a, and B goes to B. Now let's talk about the Chomsky hierarchy. Here we have four types: type 0, type 1, type 2 and type 3. And we have the language, grammar and the machines that they accept. For recursive enumeral language, we have unrestricted grammar which is accepted in Turing machine. We have context sensitive language which accepts context sensitive grammar which is accepted in linear bound automata. Context free language which accepts context free grammar and used by push down automata. Regular language which accepts regular grammar and which is accepted in finite state automata. Unrestricted grammar. The type 0 grammar generates recursively enumeral language. The productions have no restriction. There are any phase structure grammar including all formal grammars. They generate a language that are recognized by a Turing machine. The production can be in the form of A goes to B, where A is a string of terminals and non-terminals with at least one non-terminal and A cannot be null. B is a string of terminals and non-terminals. For example, we have four strings which are obeying unrestricted grammar. Now let's get to the context sensitive grammar, our type 1 grammar. Our context sensitive grammar generates context sensitive language. The productions must be in the form alpha A beta goes to A gamma beta, where A belongs to N which is a non-terminal, and alpha, beta and gamma belongs to the string of terminals and non-terminals. The strings alpha and beta may be empty, but gamma must be non-empty. The rule S goes to phi is allowed if S does not appear on the right side of any rule. Let me reconsider that S is a starting symbol. The language generated by these grammars are recognized by linear bound automata. Here we have some examples where AB goes to A beta BC and A goes to beta CA and B goes to B. These are all context sensitive grammars. Now let's take a look at the context free grammar. The type 2 grammar generates context free languages. The production must be in the form of A goes to gamma, where A belongs to any non-terminal and gamma belongs to string of terminals and non-terminals. The languages generated by these grammars are recognized by a non-deterministic push-down automata. For example, S goes to X alpha, X goes to alpha, X goes to alpha X, and X goes to phi. Here we can also consider that X goes to phi because we just need a non-terminal on the left side and a string of terminals and non-terminals on the right side. Now let's talk about the regular grammar. The type 3 grammar generates regular languages. It is the most restricted grammar. The type 3 grammar must have a single non-terminal on the left hand side and the right hand side consisting of a single terminal or single terminal followed by a single non-terminal. The production must be in the form of x goes to alpha or x goes to alpha y, where x and y are non-terminals and alpha must be a terminal. The rule s goes to phi is allowed if s does not appear on the right side of any rule. Here also s is a starting symbol. So we have our examples: x goes to phi, x goes to a, or x goes to a y. Now let's take a look at this figure. Here we can see our unrestricted grammar, context sensitive grammar, context free grammar and regular grammar. What we can understand from this figure is that every regular grammar is also a context free grammar, every context free grammar is also a context sensitive grammar, and every context sensitive grammar is also an unrestricted grammar. Hence we find how our type 0, 1, 2 and 3 are linked. From this video we understood what are grammar conventions and the Chomsky hierarchy, and how the regular language is good for scanning, the context free language is good for parsing, and also about context sensitive language and recursive enumeral language. Thank you.